Welcome to kitchen tutorial number 5. This tutorial is really more about lighting in general than it is about the kitchen, although you're going to use these techniques to light your kitchen. So, but I think this is a better way to understand it than going right to our kitchen. It's going to be easier to render this little example that I've set up, and it's going to be it's just going to be faster, and I think you'll understand it more. And what I would recommend that you do is when you get this this little example put together, and we'll talk about exactly what I want you to do in just a moment, but once you get it put together and we go through directional lighting, point lighting, and spot lighting, I would save this so that the next job that comes up and you need to light it, you're probably not going to remember all of this stuff, and you can go into this file, open it up, and play around with the different lighting settings and get a sense of what will work for your project. Alright, so what I want you to do is just open up a blank file, a new blank file. Just an 8.5 by 11 sheet size is fine. I'd like you to draw, actually I'd like you to change the design layer from 1 to 1 or whatever it defaulted to 1/2 inch equals 1 foot. And once you get that done, I'd like for you to draw a rectangle on the sheet that is roughly 15 feet by 8 feet. Once you get the rectangle drawn, extrude it to 1/16 of an inch so that it becomes a 3D object. You can also, if you like, at this point give it a fill. I use this purple color just to made it. I wanted a color that was going to show shadows and show light well. Alright, and then once you get that done, and actually let me go here to plan view, I'd like for you to draw a rectangle that will represent a wall. Draw another rectangle over here that represents a wall, and extrude these two to 8 feet, 96 inches. Wall thickness doesn't matter. We don't care about that. We're just trying to create a surface for the light to fall on. And then in the middle of the page, in the middle of the floor surface, you can draw a circle. Mine is what? It's 1 foot. See, the radius is 11 to 12 inches. Again, it doesn't matter the size. And then I made it about 5 feet tall as far as the extrusion. So when you extrude it to about 5 feet. And you will get something, if you go to an isometric view, something that looks like this. If you go to OpenGL, it'll look something like that. And by the way, this is just a white fill on the cylinder. Alright, so now that you've got this drawn, what I'd like you to do is go to right isometric, and then let's go to OpenGL. Notice that with OpenGL we don't have we have some shadowing. You can see we've got shadows here, and we've got a little bit here, and this is shadowed, but not much. There's no lighting done here. This is just default. Alright, so let's go to Final Quality RenderWorks and just see if there's any difference. Not much difference, is there? Okay, can't really tell. Maybe it's a little sharper, but not much difference there. Okay, now let's go to Command 5. So we get into Plan View, and let's go to our tool sets. Go down here to the Visualization Tools and come up here to Light. And just click in the drawing here. I'm going to put it right over here. And let's just go with it the way it came in. And let's look. Oh, but one thing we do need to do first is let's change the z-axis to 96 inches. Let's get it up in the ceiling. Okay, so we're 8 feet high now. The azimuth is at -45 and the elevation is 35.26. Now there is an accompanying document that I would like for you to open. Just take a moment and do this. It's on the website in this week's work, and it is it's a Word doc on the lighting tools, and it explains azimuth and it explains elevation and all that. I'll do that in the video here, but I thought it'd be helpful to you to have that as well. Okay, so let's take a look just at default, the way it came in. Only thing we changed was we moved the light up to 8 feet in the z-axis. And actually, let's go and look at it in front view, so we can see now that the light source, the directional light source, is right up here. And I've chosen the directional light source. That's the first one in this group of 4. Okay? All right. Now let's go to right isometric, and let's go to OpenGL and see what kind of difference it made. Made it a little sharper, didn't it? The shadows are a little more highlighted, both on the wall and on the cylinder. Let's go to Final Quality RenderWorks. Big difference, huh? Now we actually have some discrete shadows that we can see, and it sort of makes sense, doesn't it? Looking at where the light is located. Now, what I'd like you to do is, we've got the azimuth at -45. So now let's talk about that just a little bit. Let's go into Plan View and take a look here. The azimuth is the direction that the light source is pointing. If we change the azimuth to 0 degrees, it's going to be pointing in the north direction. And if we go around to the right and we go 90 degrees, let me just input it, -90, it's pointing to the east. So -90 is east, 0 is north, 90 degrees is west, and -180 is going to be south. All right, so that's what azimuth is all about in directional lighting. So let's do this. Let's point it north. So we'll go 0. Now the elevation, what this refers to is not, the elevation of the lamp, which is, what it sort of implies, but what it actually is what the angle is off of a horizontal plane wherever the light source is. In our example, the light source is at 96 inches in height, and if you were to point, let's say that your light source is like a flashlight. You're up at the ceiling, 96 inches, you're pointing it due north, up on the page in our case. As you bring the light down, as you angle the flashlight down, that's the elevation angle. So that when you get all the way down to the floor, straight down, vertical, you are at 90 degrees. Let's put 90 degrees in and just take a look at that. And I'm going to look at it in front view. And you can see that the light source is looking straight down. If I put in 45 degrees, it's going to be at a 45 degree angle to the ceiling. And if we look at it in a side view, let's do a right side. There it is at 45 degrees. So that's how that works. Now that you understand that, what I'd like you to do is to let's go back in here and go to right isometric, and let's go to Final Quality RenderWorks. And now you can see that our shadow has changed, hasn't it? Now, if I go, I'm going to go back to plan view. If I move this light source over here to the right, now I'd like you to do the same thing. Right isometric. Let's look at it again. Nothing changed, did it? So the way you want to think about this light source is that even though it looks like it's a discrete, coming from a discrete point in the ceiling where that little, symbol is, it's really it's like sunlight, if you will. It's like the sun shining down. There's so much light coming down. It's not coming from a point like a spotlight. It's just light. So you could put that light source anywhere in the room that you want, and as long as you point it in the direction that you want it to go, and as long as you point it at the angle that you want it to be from the ceiling, pointing down, that's where the light is going to go. Okay, so that's how that one works. Let's change it one more time. Let's change it to, let's change the elevation, the azimuth to 90 degrees. So we'll point it west. All right, and then we'll go back to right isometric, and let's go to Final Quality RenderWorks. And you can see that makes sense, doesn't it? The sun is shining from the east to west, and it's putting that shadow on the floor there. If I move the light source over here, we should see exactly the same thing. Exactly the same thing. So the position of this light source, directional lighting, isn't important. What is important is the azimuth, the direction in which it's pointing, and the elevation to which it's pointing. Okay, so that's how directional lighting works. Now let's I'm going to get rid of this light source, and I'm going to go back to my lighting tool, and I'm going to put in a point light. Now a point light is like a light bulb. This one is directional in that it's omnidirectional, but it's all coming from one source, basically in the room. Like if you had a light on a pull chain, just a keyless light bulb up in the ceiling, light would be emitting omnidirectionally from that light bulb in all directions. So let's do this. Let's choose that, and let's come into this corner. I want to put it sort of right there. All right, now we'll say soft shadows, and our point light specs we'll do now. We'll do none first, and then we'll go through these so you can see what they look like. And okay, weren't a whole lot of selections there, a lot of choices to make. Let's move it up. Go to our object info palette, move it up to 96 inches so that it's in the ceiling. Okay, and now let's render it. All right, so this one now is going to be position sensitive. If I go back now and move this light over here, go back to right isometric and render, it's putting light out in all directions, and you can see that it's sort of a little brighter right here where it's hitting the wall. Let's now go and look at the distance fall off and see what we can see how that changes. So right now we have it set at none. Let's go to smooth. Okay, it's a little more realistic looking. Notice that this spot on the wall where the light is hitting it has gotten more focused. And if we go to realistic, it's gotten even more focused. So again, you know, these are things that, depending on what it is that you're trying to light, you may want realistic or you may not want it, depending on the look that you want. It's just getting an understanding of what all of this stuff does. So in essence, that's point light. Now I'm going to get rid of that, and I'm going to do spotlight. All right, let's talk about the light preferences for our spotlight. We're going to go with white as our color. We have the light is on, cast shadows, cast soft shadows. We're going to select the emitter, which is going to allow us to change the amount of light coming from the source. So we're going to either get brightness from candelas or from lumens. Now, lumens measures a lumen is the measurement of light at the light source. Candelas, on the other hand, are what it's candle power, basically. And candle power is only associated with directional lighting. First of all, that's one thing you need to know. You can't apply candle power to an A bulb, you know, just a regular old Thomas Edison A bulb. Candela only works for things like spotlights and floodlights, where the light is being intensified by the bulb. And in the case of a PAR lamp, a parabolic illuminized reflector, the light is bounced around inside the spotlight or the floodlight and intensified, and then it goes out to whatever objects it's going to light. That's what candelas are about. And one candle power is the amount of light that a candle would put out on a sphere that has a radius of 1 foot. If you can imagine the sphere was somehow magically placed around the candle, and it would have a 1 foot radius. One candle power would be the amount of light that would illuminate that globe. 1 square foot of that globe. And there's 12.57 of those little squares on a globe that's that size. They're called steradians. You don't need to worry about that, but this is information that you would input from your light source. So in other words, if you were a kitchen designer and you knew that you like to use a PAR 75 with a 60-degree beam spread, you would go to the spec sheet on that and find out what the candle power was, and you could put that information in here. So right now we'll just leave it at 1,000, and then you can also set the color temperature. We can set the color temperature. They've got it at 3400, which is fairly white in color. We usually shoot for somewhere around 2800. Incandescent lights give us around 2800. So we'll just go ahead and put that in. And then our spotlight specs. This is one that I've been wrestling with for a while, trying to really understand this. The spread, well, let me back up. The beam, 30 degrees, is, I thought it was beam spread, and I guess it is. The beam, the way they're measuring it here, is that if you drew a straight line, a horizontal line right here, this angle, half of this, actually this angle from here up to your horizontal line, that would be 30 degrees, and the spread would be 60 degrees. So they're showing you the beam here and the spread here. So, for example, that PAR lamp that I just described, it might have a beam spread of 53 degrees. So I'd put in 53 here. And then why the beam changed to 5 degrees, I have no idea. But this is the number that you're going to use to approximate the beam spread of your lamps that you're going to use. Okay? This is tough stuff, and we have a whole lighting class that we teach, where it's hard to understand all of this without knowing a lot of background, but bear with me, we'll be okay. So we'll just leave it right there. Let's leave it at none as far as the distance fall off, and then let's go OK, and let's go OK, and let's place the light source. We'll just put it right there, and now, actually I don't want to do that. Okay, now let's go to let's do a left isometric view. And let's also move our light source up to 96 inches so it's in the ceiling. And let's go down here just a little bit. All right, now with this type of light source, the spotlight light source, they change from calling it azimuth to pan, and I think the reason they do that is because azimuth is associated with the sun. And that's what this directional lighting is all about over here. It's sunlight, as we saw when we moved it to one side or the other. It didn't affect. They only affect the shadowing and the light. It was only by changing the azimuth and changing the angle that it changed it. So this is more interior lighting. This would be like your can lights, for example, in the ceiling. So right now we're at negative 90. Let's go into plan view here and take a look at it. We're at negative 90 here, which is pointing east. If we go to 0, we'll be pointing north. If we go to 90 degrees, we're pointing west. And if we go negative 180, we're pointing south. In the case of a can light, it wouldn't really matter which direction it was pointing because the tilt is going to be 90 degrees. Again, that's that example of the flashlight up at the ceiling. It's at 0 degrees when it's lying there horizontal, but as you tilt it down, and you come down to vertical and you're pointing straight down at the floor, you're going to be at 90 degrees. So it wouldn't matter which way it was really pointing. Okay. Now the other thing that was a little confusing to me on this was, let's see, where is it? The, yes, look to height of, and I'm going to go to 0. And what that's saying is that where do you want the light to land? I want it to land on the floor plane, okay, which is at 0. That's where everything's zeroed out there. And if we look at this in front view, you can see that there's my lamp source, my light source, and it's hitting right there at 0. If I wanted it to, you know, land at, let's see, if I put in 30, so if I went, I would be going up 30 inches. If I wanted it to land on my countertop, for example, I could put in 36. And again, you're just going to have to play around with this until you get the desired look. I don't think that you can treat this, if you know lighting and you know how to light, this isn't going to work exactly like the real world. Just keep that in mind. You're creating an effect here, and you're getting you're approximating it as close as you possibly can. Okay, so let's put this back to 0, and let's take a look in our right isometric view at what this light source is doing. Okay, so there's our 60 degrees, or 53 degrees, excuse me, is the spread. Now let's change this beam to 25 and see go from 5 to 25 and see if anything really significantly changes. Not much, does it? Nothing really happened there. If I go to 30, not much. Let's go to 40, 43, that'll do. Okay, now there we could see a change. Let's go back to 30. Now you can sort of see the shadow up on the wall, or the light up on the wall here just a little bit. If I take this thing all the way out to 53, watch what happens. You see what happens? It gets very spotlighty. I mean, it's like, you know, being at the circus. You can really see a discrete outline of the spotlight. Whereas if we put the beam down here at 5 degrees where it was, it's more subtle. So this is so think of this beam as a way of making the beam more pronounced and more discrete in its form, with a large number, you know, a number close to the spread, and a low number away from the spread will give it a more a softer look, I guess would be a way to say that. Now if I take this beam spread down to 5 degrees, I get a real pinpoint, and if I bring this down to, let's go to 2 degrees, it should soften it up a little bit. So another example. All right, so there's your lighting. Let me do one more thing. Let's take this light source, and we have it pointing in the negative 90 degree direction. No, actually we have it at 180. Let's go negative 90. So we're pointed at that. Actually, let's do this. Let's move it. I'm going to move it over here. And I'm going to point it at 90 degrees. Where is that? I'm going to pan it to 90 degrees. And I'm going to tilt it at 45 degrees. There we go. And let's see what it does to our column. Now we've got that little pinpoint on there. Let's make the spread 53 degrees. Ah, very nice. And so there you can see what that'll do. So what I would like you to do is to light your kitchen, and I will come back in just a moment. I want you to take your time here and kind of play around with this thing a little bit. And I'm going to show you on this same video, I'm going to show you what I did with my kitchen. And I want to show you one more thing about getting a really super realistic look to your drawing. Okay, I'll play around with it and I'll be right back. Not on a new video, but on this one. Alright, well, I've gotten my kitchen all rendered, and I'm going to show you the settings that I used and show you how I did mine. But I encourage you to experiment around, do some things that you know, that I haven't done. That's how you're going to learn this program. All right, so let's go. I'm gonna get out of this view, and I probably won't go back to it because it takes about 15 minutes for it to render. And I want to warn you about that. When you start rendering, probably the best way to do it is to do OpenGL until you know, to kind of tweak it and get it what you think is going to be right. And then when you think it's right, then do your final rendering, because it does take a long time. And I've got a pretty smoking fast computer here. Boy, I think I've got 32 gigs of RAM, and it still took about 15 minutes for it to render. So beware of that. All right, let's take a look in plan view, and I'll show you how I lit this thing. So essentially what I have is get rid of this. I have 4 general light sources here. I have some ambient light coming in here. This is my directional light that I've put purposely on the outside so that I could get that shadow that you see on the floor coming through the window. And here I have 2 additional can lights over the sink, and then I have under cabinet lighting under my wall cabinets. Okay, now these lights, let's start with the directional light. Here's the settings that I used. You know, and again, I'm just playing around, trying to make it look as good as I can. You could spend hours and hours and hours on this. But I've got the azimuth. The thing that's important here is that the azimuth is at -180, and the elevation is at 44 degrees. So I've got it coming in at an angle through the window, and it's pointing south, so that it actually is shining through the window. Then I have these under cabinet lights. These are point lights, and you can see the setting that I have for them. I've got the brightness kicked down to about 23%. I'm keeping it fairly simple. I'm using you know, casting shadows and soft shadows and all that stuff. But that's about it there. I pull them forward in front of the countertop, not, excuse me, to the front of the wall cabinets, which is the way you would do it in the real world. And then, as you can see, they're sitting right down below the cabinets there. Then let's take a look at these two can lights over the sink. I have them spotlights, set a spotlight. I've got the dimmer set at 53%, the brightness value at 1500 candelas. Kelvin temperature is 2800, and here's my beam spread. I've got a 30-degree beam spread and a 10-degree beam. Now the 10-degree spread, again, that is actually the beam spread, that you get the beam angle. And what I wanted was a fairly narrow beam angle to just light this countertop. So I've got two of them here that are lighting the countertop. All right, and in addition to that, I drew in a little circle, and you can see it right there. There's a little, let me zoom in. There you go, there's the circle. And you can see that it's a 4-inch circle with a 1/16 inch extrusion, a radius of 2. And the purpose of that is so that when you see the can in the ceiling, you'll actually see it. I gave it a white color so it looks like a can light, and I did that because the light sources that we put in don't show up. They illuminate objects that they are lighting, but they themselves do not show up. Okay, so I put in a little 4-inch, and then out here I put in a 6-inch trim. So that's a 6-inch. Oops, there, I just had it. That's a 6-inch, 3-inch radius, 6-inch diameter, 1/16 of an inch extrusion, and I made it white. And then the light source inside there is a spot, once again. This one is a 60-degree beam spread with a 10-degree beam. I've got it set at realistic. Kelvin scale is 2800 again. Dimmer 53%, and the brightness value at 900 lumens. Actually, it's candelas, 900 candelas. And that's it. That's all of the lights I have in there. And so you guys try it out. I want to show you one other thing here that's important, and that is how I get the view and how I render it. So let me do this. Once you get into plan view here, now you've mucked up your perspective view, and so to get back to it, what I do is I go to right isometric, and then I go over to view, perspective, normal distance, and then I grab the flyover tool and kick it up. Okay. And then I zoom in on it. Until I get it looking the way I want it to look. There's a couple of things that I'm trying to do here. One, I want to see the lights in the ceiling, and I want to see a little bit of the sink. So I think that's pretty good right there. So let me render that one more time, and we'll see what we've got. I'll be back with you. Okay, so now let me show you how I render this. I'm going to go over to View. Now, rendering, we've got all these selections over here. What I've done is I've gone to Custom RenderWorks options. These are the selections that I made. Image exposure is 100%. I've got all the levels at high quality. That's why it's taking so long to render. I could kick these down, and you could do that until you get it the way you want it. Okay, So that's all good. Lighting options. I have the ambient info turned off. Brightness is set at 35%. Let's kick that up just a hair. Let's go to 40. Alright. Emitter brightness 100%, and white color temperature, I've got it set at 2800 Kelvin. Alright. So that's good. And then the other settings that I have are RenderWorks styles. Now, I selected realistic interior final. Now that was found in this list here, and once you select it, it pulls it up to the top so that you can find it easily. That's what I'm using to render. Realistic interior final. And as soon as I click on that, it takes a moment, screen goes to black, and then it starts rendering. I'll get back with you in just a moment. Alright, well there's my final rendering. I'm not that happy with it. I'm going to work with it some more, but you can spend hours and hours and hours on these renderings. So watch your time. On our final kitchen video, we're going to create some viewports of our kitchen. So I'll see you then.